An experimental study on using of waste marble water as partial replacement of portable water in concrete. Abstract: portable water is the main ingredient in making of concrete. Without PW, making of concrete is not possible. As there are crises of water in the world, we need to find out the second alternative of PW for making in concrete. In these research we have study about the use of waste marble water in making of concrete. The concrete was mixed design for M25 grade of concrete with moderate exposure condition. The PW was replaced with WMW at an interval of 25%, that is 0%, 25%, 50%, 75% and 100%. The cube and cylinder were casted of standard sizes and they were tested at 7 days and 28 days after curing. The result shows that as we replace the PW with WMW by an interval, the strength increases, but when we replace the PW with WMW by 50%, we get the maximum compressive and tensile strength. The percent increase in the strength at 50% replacement is: keywords: waste marble water, portable water, compressive strength, tensile strength, M-25 grade of concrete. 1.0 Introduction. As India is an undeveloped country, for developing itself it requires a good infrastructure, and for that concrete is in high demand. And for the production of concrete, cement and water are main ingredients other than sand and coarse aggregate. Approximately around 150 liter of water is required per M3 production of concrete. And as we all know, only 3% water is available for drinking, and out of that also only 1% is available as ground source. Generally in construction the water is directly bored from the ground or taken from the government bodies. Because of this reason there is a decrease in the groundwater level in India, due to which there is scarcity of portable water, and many construction work have been stopped. We need to find the other alternative of PW as these resources are getting reduced day by day. The other researchers have studied about using the primary treated wastewater, secondary treated wastewater, but no one has studied about the effect of waste marble water on concrete. As in marble industry, water is a main source for cutting the marble into desired shape. The wastewater is directly drained. This study aims on using the WMW as a partial replacement of PW in making of concrete. And the partial replacement are done at an interval of 25%, that is PW will be replaced by 0%, 25%, 50%, 100% of WMW. 2.0 Literature Review. E.W. Gadzima, 1. Effects of sugar factory wastewater as mixing water on the properties of normal strength concrete. The concrete mix of 25 MPa with proportion 1, 2, 4 with W/C ratio of 0.56. The PW was replaced with sugar wastewater in 0%, 75%, 100%. In the paper they have replaced the PW as total or partial replacement of mixing water in concrete as well as for curing it. After reading we can conclude that target strength as 28 days was ranged between 83% to 91%, but if we extend the curing duration to 90 days the concrete cubes produce more strength than targeted strength. 3.0 Methodology. Figure 1, Flow chart of methodology. 4.0 Experimental work. Cement, it is used for binding the concrete. We have used PPC of 53 grade. Coarse aggregate passing through sieve of size 20 mm and retained on December 5 mm were used. The specific gravity was 2.83 and water absorption was 2.47%. Fine aggregate was found to be from zone 3. The specific gravity was 2.68 and water absorption was 2.21%. Portable water, PW, was collected directly from the tap which was used for drinking purpose. The table 1 shows the chemical property of PW used in construction. Waste marble water, WMW samples were collected from marble cutting and polished factory in Bardoli region. The table 1 shows the chemical property of WMW with the permissible of is 456-2000. Mixed design of concrete, the nominal mix design of concrete was done according to the IS 10262-2019, and concrete specimen was designed for a grade M25. Table 2 shows the mix proportion of concrete. There is partial replacement of PW with the WMW. Preparation of specimen, cubes and cylinder were casted as per above mentioned concrete mix. Totally 40 cubes and 30 cylinders were casted for these project work. Following table indicates number of cubes and cylinder were casted. Curing, IS 516 guidelines were followed for the compacting and curing of concrete specimen. 5.0 tests and results. Compressive strength test, IS 516 was followed for the test. CTM used for testing was servo-controlled and 3000 knots capacity. The casted cube were of standard size of 150 mm * 150 mm * 150 mm. Result are shown in Figure 2 for 7 days and Figure 3 for 28 days. Split tensile test, IS 516 was followed for the test. CTM used for testing was servo-controlled and 3000 knots capacity. The casted cylinder were of standard size of 150 mm dia. 300 mm height. Result are shown in Figure 4 for 7 days and Figure 5 for 28 days. Slump cone test, IS 1199 was followed for the test. A cone is used for determining the workability of concrete. Results are displayed in table. Ultrapulse velocity test, IS 13311, Part 1, was followed for the test. These test was done to find the quality of concrete. After performing the test we have found out that the quality of concrete has come good and UPV was ranging from 3.77 to 4.18 km/section. 6.0 Dicas Science and conclusions. From the test performed, we can clearly say that WMW can be used in the construction work. As the chemical analysis was within the permissible limit as per IS 456/2000. And it can also be used for curing purpose. The partial replacement of PW shows increase in compressive strength as well as the split tensile strength. When we are replacing the PW by 25%, 75%, and 100%, there is reduction in the split tensile strength ranging from 14.96%, 6.20% and 6.93% respectively. 100% replacement is possible as there is negligible reduction in the tensile strength of concrete. Figure 4, split tensile strength of cylinder, 7 days. The consistency, initial and final setting time was found to be within the permissible limit as per IS code. When PW is replaced by 50% of WMW, there is increase in the compressive strength by 13.63% and in tensile strength by 8.03%. When the PW is replaced by 100% of WMW, there is increase in the compressive strength by 10.19% but there is decrease in the tensile strength by 6.93%. We can use the WMW as a partial replacement of PW. Workability of concrete was good. The quality of concrete with partial replacement of PW was also found good. Concrete cost can be reduced by using the WMW in construction. The amount of water saved when we are replacing PW with 50% and 100% per M3 production of M25 grade of concrete 99 and 197 liters.